Lesson 9.1, multiplying and dividing rational expressions. Now here we're going to step into rational expressions, which we want to be very careful about. It's very demanding in detail and very demanding of your knowledge of the basic operations and how they all work together. So we have to be very careful about how we do these questions. There's many places that we can make little mistakes and many faux pas and natural mistakes that we make without thinking. So be very careful, especially for ACT questions, MCAs. These are present quite often. So let's talk about a basic idea here of what is a rational expression. Well, that is a ratio of two polynomials. And we said there's monomials, binomials, trinomials. Those are all examples of polynomials. But we're talking about a ratio now. A ratio is a fraction. Okay? So that fraction then can be written with colon or as a normal fraction when we're typical to see, more likely to see. And when you have a ratio of two polynomials, it's called a rational expression. Now expression means we have no equal sign. Okay? It's just an expression, and we're being asked to simplify them. Later we'll get involved with solving rational equations, but right now just expressions. Now we've done this before with regular numbers. If you know if we have 12/8, the first instinct would say, oh, I know that 2 goes into both. That's an easy one, which means we would get 6/4. Then you realize, okay, we have 2 that can go into both of those, which takes us down to 3/2. Okay, so now we have a simplified fraction. All right, simplified by taking out common factors. Now we can only simplify this when numerator and denominator have things being multiplied. For example, another way to factor this that you're taught in middle school would be to say, what are the prime factors of 12? Well, 2 times 2 times, let's see, 3 are the prime factors of 12. 4 or 8 is 2 times 2 times 2. Notice everything's being multiplied, which allows us to cancel these out, which leaves us with 3/2. That's another way to simplify a fraction. But it is this right here that we're going to need to remember to help us through rational expressions. So if we look at this, notice that there's a y plus 4, but it is the multiplication between these things that we are going to use to allow us to simplify. Now, because we have y plus 7 being multiplied times y and 3, that can cancel with the bottom y plus 7. Okay, a very common mistake. X plus 2 over x plus 3, I can cancel those out. No, we cannot do that because they are being added. Okay, we can only cancel out if we had let's say an x out front. Then these can be canceled because of the multiplication. So the relationship must be multiplication for us to cross things out. Now this question leaves you with 3y over y squared minus 9. Now this can be factored, and we're going to do that for, there's a reason for it. We have 3y over, and this is a difference of 2 squares. So y plus 3 minus 3. And why do we do that? Well, because in B, they're asking us under what condition is this expression undefined? Meaning, undefined, meaning that you have a 0 in denominator. Okay, well, if we plug in a negative 3, that would cause it to be undefined. If we plug in a 3, that would cause it to be undefined. But we have to remember that this is a simplified version of what we started with. So we have to also refer to this part. Before we cancel, we have to respect the initial problem. So what conditions is this undefined? Well, it was undefined at -7, even though it disappeared. We have to respect it. It started out that way. And then -3 and +3. I factored it because I don't know if we would have remembered that -3 squared minus 9 is also 0. We might have forgotten that -1. Okay? Alright, so let's simplify these expressions. No. Okay, first reaction, we want to cross things out. Remember, we cannot do that unless we have multiplication going on. You say, well, Mr. Warnicki, look, we have multiplication going on between 2 and a to the 4th. But we have a minus between those two polynomials, or those two monomials. So we have to respect that first. So let's look at each one and say, well, what do they have in common? See if we can create a multiplication. A to the 4th, b minus 2a to the 4th. Well, they both have a to the 4th. Factor that out and we get b minus 2. Okay, try the bottom. They both have a to the 3rd. So we have 2 minus b. Now, we have created a multiplication problem. Now there we can cancel some things out. Alright, we have 4 a's above, 3 a's below, so we can cancel all of those out and all but one of those. Okay? Now here's where it gets a little interesting. Notice that we have b minus 2 above and then 2 minus b. So if we reordered that, it would be negative b plus 2. Now if you remember from quarter 1, they look very close. They're almost the same thing, but they're opposites. Alright, so right now we have a on top, then b minus 2, and below we have negative b plus 2. Almost the same thing as b minus 2. But we can change this. Because it's opposite, we can say, I'm going to take a negative out, and if I do that, I will end up with b minus 2. They will each change signs. That allows us to take advantage of this situation. Now they cancel. But what we've created now is a over a negative 1, which means just negative a. I don't know if you remember this, but when we did some factoring earlier in first quarter, we made this observation to have the ability to change the signs when we needed to. I think that came into play with factoring by grouping. All right, next one, similar situation. We have an x to the 4th in common, x to the 3rd. We can cancel that out. The x's, same as before, very similar question. And then we notice in parentheses we have opposites again. I'm going to reorder this so we can emphasize that they are opposites. So we can take a negative out, and we get y minus 3, which allows us to cancel those then, and again leave us with negative x. Now this ends part A of lesson 9.1.